think we better just finish this section first. I'm feeling better, kind of, but my brain's just kind of loopy today. I think it's because I took my Mucinex and not my Sudafed, or my Dayquil, or whatever it was I was taking. I ran out over the weekend, so my congestion is just kind of like a bleh. But here we go. We are missing people. I hope they're not terribly sick. Wait, she was here. But that's where she is today. Okay. And then Carrie, I saw Carrie. Okay, so maybe she's in a meeting right now, because she was here at the beginning of the day. Okay, if you guys wouldn't mind just texting Carrie and Kathy groups, and then just say we're thinking of them, we miss them today, and then maybe we won't be presumptuous, but just check on her and make sure she's okay. Thanks, Riley. And Jesus, watch over Kathy. Let's go ahead and, that would make sense why she's not here. Let's bust out this section. So we have formulas for Taylor. Sorry, it just threw me off. We have formulas for Taylor and Maclaurin polynomials. We just started playing with them a little bit yesterday. We actually had already seen the sine one because I had you guys play around with your calculators just a little bit. And so we already knew that where or what he was going to end at, but we hadn't seen necessarily where he came from. He literally comes from finding first, second, third, fourth, fifth derivatives, finding a pattern using the formula for, well, I think actually we did a Maclaurin, right? Centered at 0. If it was a Taylor, it wouldn't quite be so easy. Then we just started playing around with ln of x, trying to do the exact same thing, except, hold on, wait. If it says p sub 6, what does that mean? Did you remember this from Friday? What's p sub 6 mean? The sixth something, but not the sixth term, actually. The sixth degree. So this would be the 0th degree. Now, why am I saying that? Okay, technically, if we were talking about sine, if they wanted p sub 5, how many terms did there end up being? Does that make sense? So we can't just say how many terms, because some of them ended up being 0 and going away. So p sub 5 ended us at the 5th degree term. Now, that doesn't necessarily mean, maybe I should come up a little bit. It means let's end at the 5th degree, there we go, expansion. The reason I'm saying that is because you might have p sub 5 of x squared, and so x squared is to the 5th, and so it's x to the 10th, and then everything starts to get a little loopy, and then we have a little bit of fun. But long story short, if it's p sub 5, we're ending at the 5th degree part of the Taylor or the Maclaurin formula. And so when this says p sub 6, we're ending at the 6th degree part. So how many derivatives am I going to have to find? 6, exactly. So if I was to keep on going, we started playing around a little bit on Friday. We have 1, 2, we have 3. Now it's time for 4. I'm just being a lazy bum and not plugging or writing of x. That's a positive 2, right? I just can't write positive 2, I suppose. Then that'd be negative 6 over x to the 4th, and then we'd have the 5th, and that'd be 24 over x to the 5th. We need more, yeah? And that'd be negative 120 over x to the 6th. If you guys wouldn't mind checking my derivatives really quickly, that would be awesome possum. I'm going to go ahead and get an entire page and expand a little bit. Now this one says not centered at, not centered at 0. This isn't a Maclaurin, this is a Taylor. Can anybody tell if I zoom in on the directions, why wouldn't they want it centered at 0? Well, yeah, at 0 would be pretty bad because ln of 0 doesn't exist. But also, what do they want me to approximate? So what if they wanted me to approximate 2.1, centered at 2? 3.1, centered at 3? So whatever approximation you want, you could technically center your approximation there, so the accuracy is going to be best right around that area. Does that make sense? So I'm centering it at 1. Yeah, 0 would be a bad idea anyway. But also because I'm trying to approximate 1.1. So hold on. Let's go ahead and build our, we're building things today, build our Taylor polynomial. So what's or how does the formula work? You guys tell me. Oh, I already did write it. I didn't finish writing it though, huh? So f of 1, what is ln of 1? Okay, so I'll do ln of 1, but it will eventually be 0, plus f prime of 1. That's 1 over 1, right? So 1 times x minus 1. Cool. Plus, and then I have f double prime of 1, right? Which would be negative 1 all over 2 factorial. I know 2 factorial is 2 times 1, but just for sake of argument, we'll leave it there. So we have x minus 1 squared. And then we have f triple prime, plugging in 1, which would be 2, right? Yeah. So that'd be 2 over 3 factorial times x minus 1 cubed. And then we're going to have plus, well, guys, aren't the signs going to alternate now? Okay, maybe I just won't do the plus negative. Maybe I'll just do plus minus plus. Is that okay? So then I have minus, and then I have plus, and then I'm going to have minus again. Where am I at? F quadruple prime, so negative 6 over 1 will be, okay, minus 6 over 4 factorial times x minus 1 to the 4th, and then plus 24 over 5 factorial x minus 1 to the 5th. Minus 1 to the 6th. Oh, no, p sub 6. Sorry, we have to stop. Yeah, Justin?
Is the x minus 1, is that in the numerator or denominator?
Technically numerator. Yeah, if you were to think about it as one huge fraction. Maggie, why are you saying should we simplify? What are you seeing? Yeah. Because isn't the 2 times the 1? And isn't the 6 the 3 times the 2 times the 1? And isn't the 24 the 4 times the 3 times the 2 times the 1? Isn't the 120 the 5 times the 4 times the 3 times the 2 times the 1? They're factorials. Because this is 2 factorial. This is 3 factorial. This is 4 factorial. This is 5 factorial. So if we were trying to simplify, it might have been a little bit easier to find a pattern. Because the pattern's going to end up being 0. It's going to be x minus 1 minus 1/2 x minus 1 squared plus 1/3 1 cubed. Well, because the 2 factorial and the 3 factorial, remember the 3 factorial is 2 factorial times 3, right? And the 4 factorial is the 3 factorial times the 4. Well, hold on. But if you saw the pattern, couldn't it have been a lot easier a lot sooner? Yeah. Did you actually have to find all those derivatives if you find a pattern? Not really. So it's up to you. It's up to you. You don't necessarily, it's up to you. X minus 1, but I do want it right, so be careful. X minus 1 to the 5th minus. But the pattern was pretty basic. Kind of, sort of, maybe. What are we supposed to be using this to do? Oh, so ln of 1.1 is approximately, this is like local linear approximation. It's like a tangent line approximation, but a heck of a whole lot better. So I'm going to do like L of x equals, which is going to approximate, kind of like Euler's method too, huh?
Is that more accurate? Sure.
This is more accurate than Euler's. Actually, I think how your calculator, I heard this, I have not backed up this fact, so I might totally be wrong. But I think Taylor's and Maclaurin's are how your calculator integrates, which is kind of cool. Because if you can take a function, make it into a polynomial, and then you can integrate a polynomial always the same way, the programming behind your calculator. Yeah.
So, like, why have different ways of approximating this is the most accurate? Like, I feel like why have linearization and why have Euler's
Well, linearization is something basic that you can see at the very beginning of calculus that gets the idea without having to get us here.
It's like saying why have multiplication when you can have exponential functions.
Yeah, it's like a building. But Euler's, I think Euler's came, I think, well, he was trying. Euler's, I think, came before Taylor. As far as kind of like rolls came before MBT, so we covered rolls first.
Yeah, I get it. I just like, but now that they know everything, they know this is like
Like now that you've reached the level of enlightenment, like why have to go back? I think Euler's math is simpler. Does that make sense? Because it's tangent line, tangent line, tangent line, whereas this needs derivatives. So if the function's nasty, without a calculator program, this is going to be nasty. Because having to do first, second, third, fourth, fifth derivatives of like a disgusting function, that could be a mess. But with a computer or a calculator, like that's possible programming it. But tangent lines, oh, like give me the nastiest. I don't care. Tangent lines, I'll be fine. And Euler's is built on tangent lines. Yeah, Aryan.
So like say on a multiple choice question they gave us like do a McLaurin polynomial and could we just do linearization of Euler's again?
And just like
I mean, with linearization, you've done like a first degree Taylor polynomial. Maybe they'll give you a point out of.
But like if it's multiple choice and you just have to put that in. Did we get close enough?
I don't think so.
Really? Can we try it?
later we could try.
I have a review packet, and you guys could play with it and see. But I don't think so. You guys know the AP better than that. They're gonna have like the local linearization one as the wrong answer. Come on. You guys are like, ha ha ha. You're thinking of like my pre-cal exams, not my calculus exams. Come on. Pre-cal was like they were 10 digits apart, and you're like, well, negative number doesn't make sense for area. No. Anyway, right? No, pre-cal and calculus multiple choice were way different. Okay, peanut gallery, shush. Anyway, coming back. Having way too much fun over here. So what would you actually end up doing? Plugging in. What? You can't box it yet. What would you have to do? Okay, just plug in 1.1. And what's 1.1 minus 1 every single time? 0.1. So couldn't we go ahead and do like a 0.1 minus 0.1 squared? Yeah, I know. It's fun. Plus 0.1 cubed all over 3 minus 0.1 to the 4th all over 4 plus 0.1 to the 5th all over 5 minus 0.1 to the 6th all over 6. Your calculator. Yay, done. Okay, good. Guess what? It's going to be really, really close. Yeah, go ahead. Oh, from here to here? Oh, sorry. Long story short, how does Mrs. Leon know her square roots to so many degrees of accuracy? Maybe I should do Mr. Che. Maybe I don't exactly know Mrs. Leon's like voodoo magic of her math. Mr. Che, how does he know square root of 2, square root of 3, square root of 5, because he memorized to so many decimals because of his work in chemistry. Like you memorize certain common numbers. I have factorials somewhat memorized. As far as I saw the 2 and the 6 and the 24 and the 120, I'm like, haha, they're factorials. But basically the math also showed the factorials because every time you were bringing down the next power, so you were going to be like 2 times 1 and 3 times 2 times 1 and 4 times 3 times 2 times 1. Like, so I kind of recognized the factorials, and I'm like, oh, hey, it's 2 factorial, 3 factorial, 4 factorial. And so that way east side took away all the ones below. So I was like, oh, the 5 is left because the 4, 3, 2, 1 is gone. But you could have done 24 over 120 and been like, okay, that reduces to, I was lazy. And I saw the factorials and I went, oh, whoosh, cool. All right, so, whoo, look at this guy. They don't even give you the function. Hey, this is AP-ish. They love to give you clues. So use the clues. They love to give you clues. So use the clues. Suppose that g is a function which has continuous derivatives, and they give us g of 2 is 3, g prime of 2 is, g double prime is, and then it says Taylor. I just have to plug it into my formula, don't I? Take a second, get the clues, look at your formula, look at your forever. I don't want to just give it your endeavor, lo siento. I don't want to just give it away right away. Take a second, analyze the clues. Think about the formula. Did you guys get the formula? Because we're doing a Taylor polynomial for g, so it's g who's in there, not f, centered at 2. So my derivatives are going to be of 2. Think local linear approximation really quickly, just in case this helps. It helps my brain keep track. Maybe it does you, maybe it doesn't you. But if I was doing a tangent line, I would do y minus g, because I have a g, equals g prime of, remember my local linear approximation would be g of a plus g prime of a times x minus a. Taylor polynomial just says, but there's more. So that's where we're going to start off as a local linear approximation and then moving on. We're not trying to approximate anything specifically in this example. We're just trying to build the polynomial. That's all they asked for. So building the polynomial, we can say P3 of x is equal to, which would approximate something if we were doing it, but the third degree Taylor polynomial equals g of 2. Guys, isn't it just a simple plug and chug? And if this is a long answer, we're not simplifying, right? It's up to you. Make it match. Remember, with integration and derivatives, make it match. Like, as long as you can make sure you're right, that's fine by me. Yeah, this one wouldn't be nice. It'd be 7 halves and 5 sixths, like. Now, when this one says use a third degree Taylor approximation, we can't use it if we don't have it. Oh, yeah, sorry. Lo siento. Yeah. We went for our clubs. Our clues. Man, my words, I'm sorry, guys. It's just. And I went the wrong way. There we go. Okay, so back to example 6. Use a third degree Taylor approximation of e to the x4. Well, we can't use it if we don't have it. That's what I was saying a second ago. So, wait, near 0. Ooh. Why near 0? Because what's the limit doing? Approaching 0. So where am I going to be centered at? 0. So, isn't this really just a Maclaurin? So wait, can they hide a Maclaurin by saying a Taylor centered at 0? Oh, sure, why not? Okay, well, fine. I mean, Maclaurins are Taylors, just at 0, so okay, whatever. So what am I going to do? P sub 3, true? Third degree of x is equal to. Who am I doing this of? That guy? No, that guy. Oh. Okay, so wait, isn't e to the x his own derivative? Sweet, so couldn't I just do e of 0 plus e of 0, because that's going to be e prime of 0, right? Or f prime of 0. Times x minus 0, which is just x, yeah? Plus e to the 0, because that's f double prime also, all over 2 factorial x squared, plus, well, e to the 0 again, because that's f triple prime, all over. Hey, so wait, is the Maclaurin of e just 1 plus x squared over 2 factorial plus x cubed over 3 factorial? Et cetera, et cetera, et cetera, et cetera. I think this is another special one, like that sine of x one we saw on Friday. Riley, they said just of him. We actually haven't gotten to that yet. So before we get there, we have to make our third degree Taylor approximation of just e to the x. Why would they be telling us to do this? Because when you plug in, don't you get 0 over 0? Not equals approaching. We're not going to lose points on our FRQs. Approaching 0 over 0. Top approach 0, bottom approach is 0. Which, yeah, L'Hopital's. Maybe here's another way of doing it without L'Hopital's. Oh, interesting. Maybe this is how Wolfram Alpha does all of its math, too. Maybe it doesn't do L'Hopital's. Maybe it does Taylor polynomials. What? Why? Because you don't have to take derivatives of stuff if you can just put them into their Taylor polynomials and then take a derivative of a polynomial. Hold on, what am I supposed to be doing? Using this to do what? So instead of doing the limit as x approaches 0 of e to the x minus 1 all over 2x, I do the limit as x approaches 0 of, well, wait, I guess I can't do equals because I'm about to approximate. The limit as x goes to 0. Can I plug in a Taylor polynomial for like a function? Yeah, I can. It's approximating it, isn't it? So 1 plus x squared over 2 factorial plus x 1 all over 2x. Now what? Cancel out my 1s. What else could I do? I have a polynomial on the top and on the bottom. Can't I just cancel out my x? So I end up with the limit as x approaches 0 of 1 plus x over 2 factorial plus x squared over 3 factorial, which equals... What would L'Hopital's have had us do? Oh, lo siento, gracias. I didn't even write him, did I? We should do. I mean, literally, don't, please. Pause. One needed differentiation, the other one didn't.
I'd rather do
You would. What would you rather tell a computer to do? Learn all the derivative rules for any possible function anyone could ever give it, or just go to a polynomial and not have to do any derivatives? Just saying. Ah! There's another one. Ready, set, go. There's clues. It's a graph. Now what? Look at all this AP practice. There are clues. Given that p sub 2 of x, look at you guys. You had no idea what p sub n of x meant before Friday. Now you know it's a second degree Taylor polynomial. You sound so smart. Oh, come on. Think about the formula. That is a second degree Taylor polynomial. Take your time. Don't shout out any answers. Look at your formula. Since I gave away all the permission slips, what time are we leaving on Wednesday? Okay. I know. I know.
Have Mr. Trey do it.
You could do that. You could tutor the Calc kids and just close it up. And you guys could pop in and get like coffee and donuts to go on the way out. Oh, lo siento. Anyone not on a diet? I already have to make food for my small group on Wednesday night on Tuesday night.
Just throw it in the oven. It's fine.
Yeah, but my house is far away. Like I do that anyway. It's not because of that. I mean, like just throw in the cupcake too.
You have to make it for your
Yeah.
You gotta sweep
I'll ask her. I'll ask her. Oh, speaking of which, the 12th and the 13th, I have this right in front of me, and I totally was ignoring it all of class. I am taking polls today on, remember spring break Friday night, Saturday morning, we have to figure out what's going on. Friday after school, mostly until, I mean, it's only until like 7:15. Yeah. It made it sound like it was like till midnight. I was like, no, it's not, I promise. We could always go grab Stonefire or something after, that'd be fun. Huh? Why'd you just put quotes around food? Okay. So, sorry. Eyes on me. So, spring break. Remember, we can't do it on the 6th with the weekend that we originally planned because of space and numbers. So, we had to basically kick out Mrs. Leon, aka give her our date, and then she graciously gave us hers. So, the 12th is Friday right before spring break and right after school. And then Saturday is our normal 8 to noon with breakfast food, etc. That's what made me think of it, was breakfast food. Thanks for that, Ryan. And I'm asking preference versus ability. So let's start with preference as to whether you'd Friday or Saturday, and then we're going to do ability, which maybe you guys can vote for both or maybe just one or the other. And then remember, if you can't do either one, that Wednesday after spring break, after school, is the only makeup opportunity. Okay? But let's start with preference. Who would rather Friday after school bust it out and be done? Wow. Totally opposite, period 1. I know we have some people absent, but we're not going to vote for them. Okay, so who prefers Saturday? Interesting. Some of you don't have a preference, and so you're trying to be fair. 1, 2, 3, 4, 5, 6. Okay. Now, ability. Who is able to stay after Friday if you needed to? 1. Really? 2. Like, no, if you're able, like, just, I know. 1, 2, 3, 4, 5, 6, 7. The 12th. Okay, who is able to Saturday? 1, 2, 3, 4, 5, 6, 7. Do you guys have a track meet thing, James? Is that what's going on? Oh, you guys are leaving Friday. Yeah.
She's wearing the jacket.
Yeah, my Frenchies, I think you're going to have to do the Wednesday, I'm pretty sure, right? Okay. Friday? Okay. Okay, talk to fam and see. Because it'd be nicer for you just to bust it out, but at the same time, yeah. Okay. Yeah. Oh. Guys, hold on and pause just to talk about that, and also, thank you, Diba. Did you guys figure out what was going on up here?
No idea.
Oh, come on. The Taylor polynomial has a formula, right? What is, stop. You were thinking about the clue instead of thinking about the idea. Second degree Taylor polynomial, no big deal. We know what that is. Isn't it f of about 0? Wait, guys, look, see? Isn't it just this? Oh, but it should, because look at what they plugged in. Who is A? F of 0. Who is B? F prime of 0. Who is C? F double prime. If this is F, come on, guys, right? Isn't it increasing and concave down? So what do we know? B has to be positive. The function is increasing. C has to be negative. The function is concave down. And what on earth about A? 0 is up. Huh. Easy. Dun, 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 dun. Done. My function is concave down. My function is function is increasing. That's some fun noises for whoever's watching that video. The function is increasing. So f prime is positive, and then f of 0 is up. I don't know what to do about that. Okay, there you go. Dun, 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 dun. So what's going on in homework? Oh, look, there's more play problems. Play problems. You have to, Question, what do you think would be easier? Do you think it'd be easier to find the first derivative, second derivative, third derivative of 4 times e to the x squared? Or would it be easier to start with e to the x and then plug in and multiply? Anyway, in homework, you guys are going to be playing with Taylor polynomials. I want you to attempt as much as you can. Oh, Maclaurin's and using and finding and solving. All right, come with questions tomorrow, fully attempt it, and I'll see you guys later, Gators. Nice thing is in our calendar, Wednesday is just field trip. Bye. Bye, guys. Look at him. He's going to leave, like, what are those called?